డాట్ డాట్ ఉంది డాట్ ఈఎల్స్ లేదు. ఏ రామ్స్ ఏంటిది లియోన్ డాట్ కాన్ఫిగ్ ఓహో దాని లోపల లేవు. ఎన్కౌంటర్ ఫైల్స్ ఉన్నట్టున్నాయి సిటిఎస్ డాట్ ఈఎన్సి
సేవ్ చేసలేవు అనుకుంటా.
సిటిఎస్ డాట్ ఈఎన్సి డాట్ ఈఎన్సిస్ మీరు ఓపెన్ చేసి పెట్టుకోవచ్చు కదా బాగా.
ఎన్కౌంటర్ తెలియదని చెప్తాను.
డిజైన్ అయినా సరే
సేవ్
డిజైన్ లేదు అమ్మా ఇక్కడ.
సెటప్ చేయాలి అంత అనుకుంటా.
దీంట్లో కొన్ని ఉన్నాయి రామ్స్.
కావాలా అది ఓపెన్ చేయమచ్చా.
మినిమం 50 ఉండాలి.
మినిమం 50 ఎన్కౌంటర్ ఉన్నాయో
ఐసీసీలో ఉన్నాయా? వేరే డిజైన్ ఓపెన్ చేయవు సార్.
ఐసీసీ
ఏదైనా సరే
ఐసీసీ ఓపెన్ చేస్తా.
రామ్స్ ఒకటే డిజైన్ ఉంటుంది కదా రామ్స్.
అవన్నీ క్లియర్ చాలా టైం తీసుకుంటుంది.
రామ్స్ 4 ఉన్నాయి రామ్స్ అన్ని
చూస్తున్నాను.
సరే. So, is there any other topics like should I need to explain to you guys like I want to explain the floor plan, but all these designs have like 4-5 macros, 10-20 macros only. 30 macros. Any other topics? You guys are interested in any other topics here? Mostly practical. Like, open it now. Crosstalk analysis. Actually, prime time. Yeah, I can explain prime time today.
If you are using the India rules, you will be able to resolve the crosstalk in top layers only. But in the bottom layers, it will be there.
No, crosstalk it will report for bottom layers also. It will be there. Actually, crosstalk na. So that crosstalk thing is there na. In encounter and ICC. So even encounter and ICC cannot student. So normally ICC and encounter cannot they cannot calculate the crosstalk. Even prime time cannot calculate. Only prime time XT and prime time SI will be there. So by default industries use those. Like SI will initially when we are in the initial stage we don't run PT SI analysis. So after the design is stable and during the net list is finalized, normally industry will have like AMD will have NLA, NLB, NLC and NLD. NLA means so a user is there, like a customer is there and he has said I want a spec, I need a chip with this spec. So what that guys RTL guys will do is they'll overview they'll not write a fully full RTL code, but overall modules they'll create and what are the blocks it should be there, all those things they'll create. So roughly, and then synthesis guy they do rough synthesis. So not every logic is useful and not all things are connected. So some flops will be end at some point. So it's a off net list. So NLA that is called NLA. So in other in Intel we call it as NL 0.5 or 0.4. So in AMD it is NLA. NLB means so the RTL guys are okay with whatever the shape we have given and whatever the area estimations for the customer is there na. So what his requirements is so even if 1 mm of increase in the width of that chip, one of the chip we are doing, even 1 mm may cost forget about 1 mm, even 50-100 microns will cost crores of rupees. So what that guy will say is he'll come to the AMD or Qualcomm or whatever the client it is, he'll say so this is my budget and this is the chip I want and this is the logic it should perform. So what RTL guys will do is they'll write some rough codes and this guy will do, PD guys will go further and do what sharams. So that's how it's a rough. So then consumer at the end PD has to give the shape and the number of voltages, how the voltage will be and what the cost it will be based on the shape and based on the layers and all those things. So we'll give a cost estimation to the customer. So he'll say okay, if he is okay with that cost, so then RTL guys will go forward and they'll write some more netlist updated it is half netlist na, so they'll some write some 70-75%. Like in a day they cannot write like the whole netlist, and we cannot wait till they write the whole perfect netlist. So it has to be go from RTL to synthesis to PD, and then again to RTL, because we'll have some flops maybe sit further, like they cannot meet, so we'll ask them to add the registers, though they need to change the clock cycles and the like whatever the, if we add one clock cycle now, so there are parallel 10 paths are there, 10 registers, start point and point, start point and point, so they are performing some certain logic. Suppose in that 10, so only one path is not meeting, it cannot meet in one cycle. So what we have done, we have added a like flop, so then the whole logic will be like changed, because at one clock cycle this data is processing there, but the first like whatever the buffer register we have added now, so that takes 2 clock cycles, so the logic they need to change and the frequency they need to change. That's how. So that's how will take a lot of iterations and all those things. If the customer is okay with cost and all those things, then finally they will give 50% netlist is called NLA, even not 50, even like some 30% netlist, 50% netlist is called NLB, some 70% is called NLC, and that 100% is in like most of the blocks will be 100% in NLC itself, but half of the blocks, like some 30% of the blocks will be in our partitions, so they will not be there. So NLD, final release is NLD. So even if any changes are there, then they will call it as functional ECO. Why I came to this? What you asked? I said, so that's how. So all these steps are there now. So during this NLA, NLB, NLC, we'll run from through all the PD flow will go, all the sign off checks, PT, prime time and redoc, everything will do. But the thing is, like, we don't run SI there, because we are not that much keen at that time. Maybe at NLC, whenever we are freezing our designs, like in NLC, so like just before we are getting the full 100% at least, at that point we will run PTSI, that's it. So ICC and encounter, it cannot withstand, they cannot calculate the SI, we just give some uncertainties for the SI regions. So only PT can calculate, and in PT the SI will be calculated based on the, like for SI also in the tech file it has defined. So if these two parallel nets, if M1 is there and parallelly one more M1 is there, and if that net is they are parallel for some 100 microns, so for this we have metal one, we have some metal shape 1, we have shape 2 of M1 only, like M1 or M2 in like same metal. So if these are some 100 microns, they are parallel, they are straight, like 100 microns they are parallel. So then the tool will calculate and say, so for this net, for the net 1 it will add some cap, extra cap, and for net 2 it will add some extra cap. Adding extra cap means that cell has to drive whatever the receiver has. So that's how it adds the SI. SI means, like, normally theoretically what we'll say, whenever it is rising, it will like SI or noise, we'll say theoretical point of interview questions will be like, whenever it is rising, if any aggressor will come come down, so the signal may get glitch, all those nonsense will say so it is just for theoretical thing, but tool will not calculate in that way. It will calculate is like when two metal shapes are parallel, or when M1 is there and M2 is there. So here M1 and M2 are in parallel, or like they might be intersect, so that the tool will see. So first it will sort all the power nets. So power nets SI, the one thing with the power nets is like power or ground nets, they will not become aggressors and they will not become victims also. So there is no SI concept with VDD or VSS, like power or ground nets, because they are always stable. So the thing happened is like they'll calculate, they'll see the nets, clock nets it will see. So after taking all the clock nets, it will see where are the clock nets are there, and is there any parallel shapes, metal shapes. Net is different. Net means like all the shapes we have, everything is net, but the shape will be there now, that M1 shape. So whenever we have any parallel shapes with the clock nets or with some other like high power nets, like clock nets itself, there are no other high power nets. So that's how it will calculate. It will add extra load on that, and it will add extra load on this. So when it can, like the tool can drive both the nets now, like our design can drive both the nets. So they are SI that's how they calculate the SI. So then they can withstand the SI, like what are the effect it can happen. I think you got my point. I think you can give me one book. I will show. Hey Ram, सुन ले Ram. ये ना
राउटर नेटलिस्ट को करना पड़ेगा. So you can't say as per block level. We need to do top level is full chip. We are doing only for block. And when they're going to divide drives, all those things. Even metals also they're going to divide. ICC ने ఎందుకు దీంట్లో ఓపెన్ చేయొచ్చుగా దీంట్లో రికార్డ్ అవుతుందిగా
Floorplan కదా
సర్లే
అరే ఆల్రెడీ ఇది ఓపెన్ ఉన్నది సరేనా ఇంకో
రికార్డ్ చేసే మోడ్ లేదని అంతే let it be
రైట్ అబ్బా
so router networks only we going to
same design
SI,
open
and there will be three models
So if I explain Floorplan in ICC now, you guys will
This is the encounter. ICC only.
It is ICC.
only current wave.
You know ICC.
Voltage. ECSM built in voltage wave.
So that's all. I think you got my point. So I'll explain that I say. So the thing is like, so in our design, speed prime time tool takes all the shapes of the clock, the M1, M4 or M5, the shapes will be their clocks. So first it will take all the clock shapes and it will see is there any parallel bits. Even data also it will check, like for 300 microns, for 400 microns if they are parallel. So because I think you know the concept of capacitance. So SI is because of capacitance, coupling cap and like side wall cap, all those things. So the thing is like this is a plate and this is a plate and in between that we have like insulator. So that's how it becomes as a capacitor. So what it will do is like it will calculate all the shapes. It will take all the shapes parallel and then so it will check in the like text file. So suppose these both are M1 and these both are M2. So what it will do is like for M1 if they are 100 microns parallel, what is the like capacitance it can produce. So these both nets, these both shapes, what is the value of that capacitance value it will generate, because capacitance means having two plates. So what is this capacitance value? Tool will calculate based on the like metal layer and the text file. So then it will add that load on this and it will add that load on this. So even after adding the load, if we get the same data, no trend violations and no timing violations, that's how it is called SI. I think you guys understood. The main aim of SI is like if we unexpectedly if we got any like other constraints, the delay may increase or delay may decrease because of the load. So then only like our functionality should not change and the tools or like one of the trend violations, cap violations should not encounter. We should not encounter. So that's how. What that it means like it is just adding some load, either plus or minus. So we have some
data set
100 FPS of load on that. So either plus 10 or plus minus like minus 10. So 90 to 110 it will check. So if this net, what are the driver here it is there and what are the receiver it is there. So normally before SI it has some 100 PS of load, pico PF capacitance, picofarads of load. So after calculating the SI, these two metal shapes are creating some 10 picofarads. So what tool will do is like for this shape it will add plus 10 and minus 10. It will calculate timing, adding and subtracting. For this it will add and subtract. But normally, so if it is data path now, then it will do plus and minus. But if it is a clock path and this is a data path now, so then how our clock path will be aggressor. So it will take this as aggressor and it will only decrease that. And for the victim it will increase the load. So even after increasing the load also, the tool meets the timing, like the path meets timing, cap, variations, everything, then it's done. That is SI. I think you guys understood. Understood the plan flow?
Fine.
So that's a maybe don't confuse like maybe like for now you might be confused like what is all these nonsense or like capacitance, load, all this. If you see prime time like timing reports na, there you see all the nets and then delay values, tran, cap, delay and the increasing part. So our SI is just like here the cap section is there na, so it will just in if you see compare if you take one prime time report of normal without SI and with SI, so there will be no change. It will just change the cap values. So that means it is adding either extra cap or decreasing the cap, and based on that tran will change. If the cap is changed, tran will change. So that's how tran will also be changed. If tran changes, delay also changes. So that's how. So the capacitance is a matter.
Means the tool is measuring capacitance or
Tool is
First of all, you need to know see, for SI, what are the input?
let us complete our question.
actually in crosstalk analysis, what exactly tool is measuring that? See, capacitance.
Yeah.
or
Capacitance only. And one thing I just want to know, tell you. So whenever you are working na, not only here, so anywhere you just focus on what tool reads. So suppose if you are going for a 2-year-old kid, and if you say all this nonsense, he will not listen, because his inputs are something. His inputs he will take only certain inputs. So if this laptop is here, you cannot take joystick and without connecting to the joystick you cannot play, because these have some like certain inputs. In the same way, you learn what is ICC inputs and what is placement inputs. Not only placement inputs, what the engine reads. So for the SI, we have lot of, in SI or noise, we have lot of theoretical explanations, glitch may come, functionality changes, design goes, everything. Why? Because of why it is going. Only because of load. Just because of load. Power is a matter. Even because of power also the load changes. Either the load decreases or load increases. So I think you got my point. So in that crosstalk, the load itself is an input to the tool. So you are giving to the tool, prime time tool, what you are giving. You are giving the power, everything you are giving. But what tool takes at calculating at the crosstalk is only the load. It cares about the load because the functionality. So you may say, so the simple thing is like he is saying he has drawn like a theoretical thing, you know. So aggressivity is rising, clock is rising fast, and when data is going down, it may have a glitch here. So that's the normal concept you have. So how tool takes, I'll explain simply. So forget everything you know, and I'll simply. So how tool calculate these glitches, like it will just calculate. So these two nets has to be parallel at some point. So it cannot be like suppose net 1 is there. This is clock net. Some C net 1, clock net 1, and the shape is like it is going from M1, M2, M3, M4, and M5. Suppose it is going here, and we have net 2. This is data net. So if just it goes from here and here, it will not cause any like SI. As you know, it cannot cause if only this portion is touched. But suppose this net 2 is crossing like this, then only it will cross. So that simple section, so even all the theoretical values or whatever the interview you give answers, so you only say whenever two nets are parallel. That's how what you say, So you just analyze why you say that nets has to be parallel. Why are you saying that? That is the thing. So capacitance will come whenever they are parallel. So that's how. Capacitance is the input for the load. So whenever the net is like this whenever this data path is coming from here to here not this, from here to here. So what tool will do is like it will calculate normal load for this and normal load for this, and it will give the timing. Even PT-SI timing also will be same without SI or with SI. But when you give like when the net is not this and this tool will check whether are there any parallel nets, because whatever the basic thing we are saying, the basic thing we are explaining is like whenever nets are parallel. So that's what now we are saying. So that is a tool input whenever nets are parallel. So it will check where are the nets like crossing parallelly, and it should be, and this is also M3 and this is also M3. Even M3 M5 can also induce. So that are some other rules. Hardly it doesn't matter like that. So but it has to be there. It has to be an M3. It will check where are the metal layers are parallel. Different metal shapes. Like one shape should belong to one net and one shape belongs to one other net. So these two nets are not same. So whenever it is parallel, what is doing is like, so our concern is like, because this is clock and because this is data, what will happen, this data may rise like may come fast or slow. I think you have seen na? So because it is rising, it may come up and it will go down, so that means delay will be decreased. And if it is also coming down, it will come even faster. So we have two conditions. We will explain this only in the interview. I think you all guys will explain the same, I think. So what happens in the tool is like, in this it will calculate the capacitance here. So this M3 and this M3, when two plates are separated with this much width, so whatever the insulator will be there na? Sorry, this whatever the dielectric will be there, spacing, so it will calculate these two plates, normal capacitor, these two plates with this much width, with this much spacing, with OD as an insulator, what is the capacitance it is, so it will calculate the capacitance. So by default tool will consider clock as an aggressor, so it will not add or decrease anything to the clock. So it will not do anything to the clock. For data, what it will do is like, so suppose we normally this net capacitance is 100 picofarads. Suppose this net capacitance is 10 picofarads. What the tool will do is like, normal SI is done. So whenever it doing normal prime time reports are done. So whenever it is calculating as an SI, what it will do is like, when it is calculating the hold, it will do 10 picofarads minus 10 picofarads, like 100 picofarads minus 10. And when it is calculating the setup, what it will do, 100 picofarads plus 10 picofarads. So now the case is done. So even if it gets up and down, if this path meets now, this hold and setup meets with this condition, adding this load and decreasing this load for setup and hold, if this meets now, so even if we get this glitch also, it's okay for us. Whether it become fast or slow, it is okay for us. I think even if you don't understand, I can do. Is there any doubts on this? I think this I have explained as little as much.
Why you were subtracting the hold case, why you were adding the setup case?
Hold it is just thing. So in interviews, many guys may ask in any different view, what is the hold like equation, or like what is the hold like what is hold check, why we do hold check.
Just we need to
The constraint for the hold is like, it is a limited, so at least this space it has to be stable. There is a time, forget about all the clock cycles, everything, just it is just like for 10 seconds it has to be stable. So what all the to violate the hold, we are doing prime time analysis or like what are the timing analysis, it is just because we want to violate, we are using SI because we want to check whether it is violating at the worst case. So at the worst case, so if I say I have to be stable for 10 seconds, so what is the pessimistic case? In the 0.1 second itself I can move. So that depends. So in the same way, that we have a signal that has already went to some because of its load, it has to be stable for 10 seconds, but because of that load it is stable for 15 seconds, and we have some 10 picofarads of crosstalk with that. If we add the load, it will become even positive. But what we should do, we should see whether it is violating. So that's why we have to reduce. So that tool, simple thing is like, hold, it should come in between the time. For the setup, it should come after the time. You got now? In simple way, we have some certain time as a margin. This is a 0 seconds or something. We have time. Hold, every time it should come in this period. And for setup we have clock period. Every time it should come after the period. That is the intention of our and the tool. We want to make violate. When it comes after this only, it will violate. When it comes in this only, it will violate. So that's how. In any interview, if we ask some load, magic, or whatever it's a load, capacitance, stand, everything, if it makes the signal to unstable fast, like change fast, like in this period, it is helpful for, it is pessimistic, and that we need to do, because for the tool we need to make sure that the hold fails, then only we can fix. Because in the design, if we go on to the silicon, if that fails, then it will be a problem. So here itself, in the logically, what are the pessimistic case we have, we'll apply and we'll make that fail, and then we'll fix it. Even the tool calculates in that way. So if we add that now, already this is a 10 seconds. Already because of that load, because of this load, normal load, it is coming at 15 like some 15 seconds. Already it is passed. If because of this load, it is giving some 10 picofarads. If you add to that load now, it will come in 16 seconds or 17 seconds. It doesn't like, we don't need to do that analysis to make it pass. We are doing all this analysis to make it fail. So that's how you got my point. Even for the same for the setup, if you decrease the load now, then we are not like doing, no need for analysis itself. SI analysis itself, no need. We need to calculate the SI. We need to take that cap value, whatever the cap here it is there, and then we need to make sure they fail. They should fail setup and hold. Then we'll fix it. So that's how. Yeah, actually different widths now. So the I think last two classes I have explained this different widths. I'll say. So the point is like, we can have M1 also in 50 width as 50, but normally we'll use that like hardly 0.032 microns, 0.04 microns, even not 0.04, 0.02, 0.01, with that microns only we'll do, because we have many standard cells, we have lakhs of standard cells, and after that standard cell, whatever the layer we have is M1. So if the M1 width itself is having like a larger width, so to access the pins, we have the pins, standard cell pins. So if the pin is like suppose we have a buffer, so it has two pins, like A pin and Z pin. So to access that pin itself, we need a 10 microns of what is called net to access that pin. So if the M1 itself 10 microns, then to put that via, like from top level, we need to get the power not only power to calculate the signal, like even the signal, it has to travel through the current. So whatever the next to that it has to be even more bigger, it should be there, because if it is small standard cell is giving the power, M1 is taking the power, but M2 will not take. So definitely M2 should be more width than that, so that it can travel. When it is coming from M2 to M1 it's okay, even if it is less also it's okay, but it is because it is going to standard cell itself. So standard cell can, like, we can get, I think you got my point. We have two cells. This A pin should connect to this Z pin. Here M1 width is 10 microns. Here the M1 width is 10 microns, but M2 width is 1 micron. M2 width is 1 micron and M3 width is 0.5 microns. They are connected in M3. So from M1 they went to M2, and then even M3 they have connected. So now what will be the timing? The standard cell is giving the right slope, like the signal, whatever the output it is giving the tran, standard cell is giving the right tran. Even the M1 is taking the it is taking the right signal, but M2 what it is making, because of its M1 width is like 1 micron, so it is reduced the channel. So it's just simple. We have aquarium here, we have aquarium there. So from there we had some big pipe, and from here we had a big pipe to get into that, and like the water is coming from that aquarium to this aquarium. There the pipe is big, so where we'll make that hole to aquarium, will take with the some 10 microns pipe, and then we'll connect that to a 1 micron pipe, so it will be small. So will the water will get is fast. So wherever it is less, it is going with that speed only it will get. So the thing is like, however it is going above, so in above layers only the signal has to be traveled, because we cannot route our whole design in M1. We cannot route our whole design because somewhere it has to cross. So even if we can route M1 and M2 in like even M1 in horizontal and vertical. So this is our design. We can route M1 in horizontal and vertical. So suppose one M1 is going from here to here, a pin here is there and a pin here. So all the signals present here should not cross this. So that's how we cannot connect like that. So what we'll do, we'll make only M1 horizontal. That's how we can make as many possible lines as we can, and then we can make M2 vertical, so as many lines we can, and then we'll make VR. So at that VR, the you anyone like that's a good question. Like if anyone asks you why M1 width is small and M2 width is more than M1, because from M1 it has to go to M2 and it has to travel, and it has to somehow it has to come to M1 itself. So when one guy is giving some input, that guy should get the same input. Worst case some little, but it should not be like pessimistic, like we are not getting the input at all, like we are getting the worst. So that's how when M1 ultimately power signal, like whatever the current has to go to standard cell. From standard cell, this standard cell has to give current to this standard cell. So they are placed a long distance. So what this standard cell is doing, this is giving current to M1, this is giving current to M2, and this M2 is giving current to here M1, and then it is giving to this standard cell. So somewhere here it has to make, in this processor it has to be optimistic, it should give like make it fast. It is not like standard cell is giving 10 amperes of current, and suddenly M1, because of its width, it cannot withstand 10 microns of current, so it will give only 1 micron of current, so this cannot on. So the current should be like equal. That's why as we go above now, we are making. So why we have to go above? Because in one metal layer we cannot route our design in one, so we can go to second metal layer. Even if our complex, here we have complex designs, so we cannot route in M2 also, we'll go to M3. But we have clock and we have clock, it has to be even more faster, so we go for M4, M5. But even clock we cannot route in a M3 or M4, M5, so then we go for M6, M7. But we have power mesh, we have to make power as more optimistic, so that we have M7, M8, M9. Even we have power bumps, so now till M9 we care about only our block, but in full chip we have lot of bumps, like lot of blocks are there, that blocks has to be optimistic, they should get the power immediately. That's why we go for M10, M11. So that's how, I think you got my point. So that's the reason. And vertical and horizontal, just because like only when we have some 10 metal layers, so no other way is there, it can be optimistic than vertical and horizontal. So if we put M1 as horizontal, that's it. Whatever the number of lines we have, like whatever the number of tracks we have, all the tracks we can use only for M1, and then all those tracks are free for M2 and all the layers also, they can also use. So that's how. So when we have a design with 10 number of metal layers or 11 number of metal layers, horizontal and vertical will give more number of routing resources, more number of tracks. That is the most optimistic one. So that's why we give. If we give vertical or diagonal, then one more. So if we give diagonal, M1 as diagonal, or like some other thing, what it will do, if it is diagonal, M1 will go from here to here. So the next M1 has to cross like this only. So all nets has to be diagonal, but it cannot be. Suppose we need a cell here and we have a cell here, they both need to be connected. If M1 is horizontal, M2 should also be horizontal, or like they have to cross. We can like, and why we have only horizontal and vertical wherever we cross there is a max possibility of putting a VR. Suppose if they are going like this, and if we want to make a hole here, it is not optimistic. But when we have exact cross sectional, we can make that hole comfortably and we can align that VR. So whatever the power it crosses it is optimistic. So that's like leave now. So that's all something we will learn based on experience. Encounter none. So is there any other topics to discuss? So at least you are facing today, you have any interviews? All guys have interviews today? Only 3 guys have? Oh, okay. So any, like at least any interview questions, like or like any doubts about clock or all that?
Why clock getting 6 hours?
Yeah. Last time I said I will say. So clock getting is some big concept. So I'll say. Uh, so the thing is like we have clock, we have clocks. Suppose in our design we have 100 clocks. So I think you can go like later you can see dot leaves. You open a dot leaf. In that we'll have a standard cell. I think I'll open. We have a dot leaf. Oh shit. Hey, dot lib should not be binary format, man. It should not be in binary. Dot db will be in binary format. Hey, they are not encrypted, man. So if you open any dot lib, what will have clock getting we are seeing now? So if you open any dot lib, so what we have in the dot lib is like, so we'll have a cell name and the pins, what are the pins it has, and what is the logic, and from A to Z, suppose it is an AND gate, from A to Z there will be an R, from B to Z there will be an R, and from A to Z what is the time it takes and what is the power it takes, from B to Z what is the time it takes and what is the power it takes. For all these things we'll have lookup table, so that's how we can calculate all those things. So there what happens now, so that power for library for all the sequential cells, the power will be more, because that sequential cells has to be manufactured, so that they have to be designed so that the input trend, output trend, they should maintain the same, because we cannot give up on our clock cycle. Clock cycle will reduce, duty cycle will go. So for now you assume like for clock cells, input trend and the output trend should be maintained. So for that they'll add some, for clock cells they'll manufacture, so because of that thing they'll consume more power. So what unlike wise or like Samsung team will do, we don't know, I don't know. So but because of that they'll calculate the more, they'll take the more, consume the more power. So suppose we have 10k of clocks, 10k of flops in our design. So for all those flops, for in library the most consuming power consuming cell is the flop. Even for C2Q or D2Q, C2 means CK2Q or D2Q, or like reset, from reset or everything, flop consumes more power. And just because clock, like one of the clock is a high frequency rate, so it will switch, it has to switch every time, and it will consume that data. Like if we have, suppose in data path we have an AND gate, it may switch on like for every once in a clock cycle, or in every time twice, or some for 100 clock cycles also it may not switch, but the inputs may remain same. But for the flops, input will change for each and every clock cycle, and our now the time period is like, it is in gigahertz, we are doing in 3 gigahertz, so that many times per second it will be short. If it is like go on for that, like if it is short, like for it clocks every clock cycle, and if that stays for 1 day or 2 days, that chip may damage because of that power. So what may damage or may not damage, that's okay. So every time for every clock switching it will take some power, but there are some cases input may not change, input may depend on some other cases. Suppose we have a mux, So for mux we have given some input enable, we have given that in enable signal is coming from something, and that mux output is going to some different flops. So that whatever the mux it is 2 by 1 mux, and the select line is always 0, and that 0 is always like it is set case analysis are there, or like it is the data is stable for some time. So the mux is not operating, but even then clock has to operate for each and every clock cycle. So it's waste of time. It reads the same data in the D and it will give it the Q. Already the data is 1. Suppose the data is 1, D, the input at the D is 1, the output at the Q is 1. So even for 10 clock cycles, 15 clock cycles, the 1 remains the same because of that select line. It may there might be, I'll show you here. I'll just casually I'm saying, so this might not be a real case. Suppose in some mode there is a mux, and from this mux we have lot of flops, and there is a select line. In this particular mode the select line always will be 0, and when it is 0 it will take this input, and this input might be stable. This is stable, it is coming from something. So only when it is 1 we have to take this input. This input is changing every time, every clock cycle, or some for 10, assume some 10 clock cycles or something. But whenever it is 0, all these inputs will be remain same. So the output should be remain same. So we don't need to give every clock cycle whatever the output we are it is already there, we are giving the same output from D to Q for every clock cycle. So instead of doing that for every clock cycle, if we switch off that flop, if we switch off that flop for some time now, then that many clock cycles short time will be there now. What is the flop is doing? Whenever there is a clock pulse, it is the CMOS and NMOS is going to switch on. So at least at some millisecond the CMOS is going to be short. That means like the flop is going to be short. We know, I think, whenever even the inverter also, for some time whenever the signal is rising at 0.5 volts, like both will be on, like it is some short current will be there. So we are saving that much short current for 10 seconds. Suppose if that for these 10 flops we are doing that for 10 clock cycles, suppose it is for 10k of cells, so we have saved a lot of data. So that's why what they have done is like they have included a flow this is present in DC itself, so we don't need to do anything. DC, ICC, they have inbuilt have this feature. So what it will do is like DC, it will send some random inputs, and based on the random inputs and the constraints we have, what are the SDC we have, based on set case analysis, false path and all those things, it will check what all the data is going to be stable for this much time, and what all the flops are dependent of this data. That means that some data path is going to some flops. So what are the data paths that are going to be stable for 10 clock cycles or 15 clock cycles, you calculate, and what are the dependencies, it means what are to all the flops, what are the flops it is going to. So what it will make is like for all these flops it will add a common cell. So now the clock will not go directly, clock will go through this cell. What this cell will do is like it will not give the clock directly, it will give from the enable signal. What it will do is like whenever the data is going to be stable, that means stable, tool will generate one enable signal, and that enable signal will give it to that one cell, some random like that is a cell, that is a special cell we have, and to that cell will give. So whenever it is enabled now, so until it de-enables that, like from 1 to 0, until then it will not give clock to the register. So when we don't give clock to register, but VDDBS is been there because it is placed in the rows, so VDDBS is connected. So that means that clock is maintaining the output, that's it. It is not taking the input to output, it is just maintaining the output, and it is not switching. So for these many clock cycles, these many flops are not switching because of this cell. So whenever the enable is like 0 na, then it will send the clock. So that means data is changing, each and every D point will go to Q point. So what are the special cell is there na, that is clock getter. So how it will be? So clock getter we don't add manually, even RTL guys, synthesis guys, no one adds clock getter manually. it is already tool has been programmed such that it will check, it will group the flops, it will group the data paths, and it will check which data paths are stable for some time, for even for changing the random inputs also. That doesn't impact the data path. Why it doesn't impact? Even if we change the inputs, the data path should change, like all the outputs of the gate should be changed. Then why it is not changing? I'm saying, so even inputs may change, but the data path may remain the same value. There only we'll add the clock gating for all those corresponding flops. I'm saying that statement. So when the inputs are changing, the data path has to change. That is the thing. Then why it's not changing? It is because of our constraints. So the main input of clock gating is our constraints. Set case analysis, false path, all those things will be there. Set multi-cycle path, all those things. If a flop has by default set multi-cycle path 10, then for every on the 10th clock cycle only it can switch on now. No need to switch for all these 10, because the data will be stable. That's multi-cycle path. We have put set multi-cycle path 10. The data is stable. So then we don't need now. So that's all. So we may, based on our constraints, what tool will do is like what all the data paths are going to be stable, and all these data paths, what it will take is like to which flops all these data paths are going to be, and it will make hello ఇండియన్ పెట్రోల్ బంక్ ఉంది కదన్న, ఇండియన్ పెట్రోల్ బంక్ తెలుసా మీకు? మేడిపల్లి పెట్రోల్ బంక్ నుంచి ఎగ్జాక్ట్ లెఫ్ట్ తీసుకోండి. లెఫ్ట్ ఒక గల్లీ ఉంటుంది, 5 floors బిల్డింగ్ ఉంటుంది. దాని గల్లీలో కొంచెం ముందు వెళ్తే 15-73/1 గేట్ పైన రాసి ఉంటుంది నెంబర్. ఏ డిపో నుంచి వస్తున్నారు? చెంగిచెల డిపో నుంచి. మేడిపల్లి నుంచి వస్తుంటే పెట్రోల్ బంక్ వస్తుంది కదా, పెట్రోల్ బంక్కి ఆపోజిట్ సుమా రెసిడెన్సీ వెనక వెళ్ళాను. సుమా రెసిడెన్సీ ఏంటంటే పెట్రోల్ బంక్ దాటిన తర్వాత లెఫ్ట్, పెట్రోల్ బంక్ లెఫ్ట్ ఏమో మా ఇల్లు. సుమా రెసిడెన్సీకి వచ్చినారా? కాదు, దాని వెనక గల్లీ. ఎగ్జాక్ట్ పెట్రోల్ బంక్ ఆపోజిటే ఉంటుంది, ఆ గల్లీ తీసుకోండి. అక్కడ ఒక 5 floors బిల్డింగ్ ఉంటుంది చూడన్న, వైట్ కలర్ది. పెట్రోల్ బంక్ ముందే ఉంటుంది ఆ 5 floors బిల్డింగ్, ఆ గల్లీలో. ముందుకు వస్తే ఒక 3 floors బిల్డింగ్ కనిపిస్తాను మీకు. దాని పక్కన ఒక 2 floors బిల్డింగ్, అంటే G+2 ఒకటి ఉంటుంది, దాని పక్కన G+1 ఉంటుంది. ఆ G+1 దాని పక్కన G+1 ఉంటుంది, ఈస్ట్ ఫేసింగ్, 15-73/1. అదే నేను కిందకు వస్తున్నాను కొంచెం. అక్కడే ఉన్నారా మీరు? అవునవును, కార్ ఉంటుంది అక్కడ. ఓకే, బయటకు వస్తున్నాను. Am I repeating many times? No, like am I repeating that? No, I just want you to guys to explain clearly, so that's all. అరే ఇంటి ముందు వాటర్ కనెక్షన్కి వచ్చింది చూడు, సరేనా? ఆ పంప్ తీసుకుని ఆల్రెడీ ఉంది చూడు ఇంటి ముందు. బాయ్. So that's all. You got my point now, clock getting point. So whenever you go in interview in future, if anyone asks now, you explain this much detail and don't forget. I have explained this much clearly now, so you don't forget and explain this, so it will be done mostly. So
settings you will be
clock getting ICC2 now. ICC2 don't have that many settings. I have done long ago, man. Like there are many scripts will be there. So almost 2-3 years back I have worked on clock getting, so I don't remember the settings. but we don't do anything, like the tool does anything. So for doing while doing clock gating we just need to know these are the clock gating cells. That's it. That means the master name will be there so whenever we see in that report based on that master name you should say okay, this is a clock gator cell. So that's it. If you know that is enough, because in future if you ask like is there any clock gating in your design, so you based on that you should say yes, this cell is there, so that's clock gating cell is there. That's it.
It's a default or not, we need to maintain it. It's
Clock gating it will not on default, but normally like you don't do from scratch now. In industry we don't load netlist, load def, load all those things. We don't do SDCs, everything. So the one flow will be set. So from that flow all the inputs it will get, like whether it is a clock gating design or not. But what I am saying is like, so to debug, so suppose in your design there are clock gators. In your timing report we are seeing a clock gating cell. If you see the worst path or some random paths, time violating paths, you are seeing a clock gator. But designer said we don't have any clock gating, or there is a not clock gating cell, or like that clock gating may give high delays or like unrealistic values. So then only we need to check, okay, this cell is giving this much delays, whether my design like should contain use these cells, or like this cell is wrongly placed. Like what happened is like in a full design all designs may not use clock gating, 1-2 designs might not use, but some CAD guy or like what are the who has written this flow that might have put clock gating on for even you also. Tool will work in some other way, it may externally add some clock gating cells or something. So you should just know that there is a clock gating cell, so in this path this cell should not present, but it has present, so that means there is a clock gating path. So you can ask the like a designer, or you can mail to your lead, this cell is giving high delay, or like this cell is giving unrealistic values, from this cell the clock period is changing. You can say that. That's all. If you want to, yeah, that's I'm going to explain. So the thing is like, okay, I'll give it to you only. So what are the ways to check to add a clock gating? The clock gating, I said that is a cell and there is some logic inside it. Which logic will perform our requirement? What is our requirement? Just tell me. For clock gating, what is our requirement? Not that requirement, man. So what I am asking, like I said clock gating is a cell. There internally it might be a logic or something. So what logic serves our okay, I don't know. The thing is like we have an input clock and we have an enable. Whenever the enable is there, then only clock should go out. Whenever the enable is 0, the clock should not go out. So what logic will serve this? That's all. So what you say randomly and or not. At least you know you say randomly and or not anything. So if you draw like who all saying it is and. So anyone come here. Anyone can come here. No, book this contract. So you write, sit there. You write a waveform clock. Okay, I'll give the inputs. You guys also prepare. So this is my input. This is my clock. And this is my enable signal. You don't do anything to this. You just write based on the AND what will be the logic, how it will be connected. Don't confuse. I'll say. So what I'm saying is like I have said there is a flop here. There is a flop. There is a D pin, data path, and there is a CK pin. This CK pin will come from clock normally. But what we have added, we have extra added a clock gating cell, and for the clock gating cell we have added a enable signal. So you said this clock gating cell is a AND gate. Forget about this logic and forget about this logic. What this cell do is like it has to give a clock. to this clock. That's it, huh? So what we need to get, output of this clock gating cell should be a clock period. That's it. So you said AND gate will serve this logic. You just show me in the waveforms. So this is the inputs I said. So this is the inputs I have given. You just draw the outputs. Show it to them. This. So I'll explain. This is 0 seconds. This is 5 seconds. This is 7.5. This is 10. This is 12.5. This is 15. You may use this. Clock gating now, even like 6-7 years guys will confuse and they don't answer. What is the reason? You just draw the output. AND gate output. AND gate it can go staba. Oh, it 10 దగ్గర వస్తుందా? Okay. Yeah, that's good. So the enable is an input to, for AND gate we'll have two input pins, A, B and Z. So enable is A, clock is Z, you just clock is B, and you just draw the waveform of an AND gate. So it's done. So for all of you except that guy, where the clock is getting on, like what is where the output is coming 1. Okay, I'll see. I got 10, this is 10 and this is 2. Same. Okay. That's the same. So you all have drawn the same equation. So now see what we want. We want a clock. We want to give clock to the flop. And what is the time period of our, suppose, what is based on this diagram, what is our time period?
10.
How it is 10?
Complete cycle.
In one complete cycle is done it in 10 seconds. So based on this 10 seconds, that means or 10 ns or 10 ps, what are 10 seconds, 10 unit. So based on this, we'll do hold check and setup check for the flops, all the flops. But what is the clock you have given to the tool, like to the flop? What is the clock period you have given? You just see the waveform, like what you have given. The output came at 10 and it went to 0 at 12.5. That means from 0 to 12.5, the duty cycle whatever you are giving is 2.5. So in that 2.5, the hold check and setup check need to be done. So is it the clock? It is our actual clock? Our actual clock should be, it should, like whenever one clock cycle is there, so whenever you are giving to a flop, even one clock cycle, it should start, it should maintain the duty cycle, it should get off and it should go there. So this complete cycle is clock cycle. It is not that even like that 0 is for some, it can be more time or it can be less time. That is duty cycle. You need to maintain that duty cycle. I'll explain the duty cycle also. So for now you have given the wrong clock. So setup and hold checks will be fail to that flop. All the setup checks and hold checks are like nonsense. They are junk because we have given the wrong clock. So then AND gate will not serve our logic. That is the thing now. AND gate will not serve. So then what we need to do? So this is what, like most of the cases now, you just don't learn. Like the thing is, like in the morning when I came and asked like have you guys done our assignment, you said no, like you haven't done. So that's why it's like, if I go on saying now, I may explain about the universe, I may explain about the sun, Rams, I may explain about anything, but you guys will just impress on that second itself. Like when I say something now, you guys will just impress oh, this is mind doing, that concept is good, I have not learned, this is new, that this. Then later you will forget, that's it. If I say some A, you should learn B. Then I can say C, D. Then you can learn E, F. So if like today I'll say A, next week I'll say B, next week. So that's how it should not be. So in industry also it will be the same. So actually the thing now, this industry itself is not good industry. This is, I'm saying now, this is the one of the worst industry. The work culture and all the these especially these Andhra guys, North guys now, all these nonsense guys came, selfish people. They don't explain, even your lead, they don't explain the flow, they don't explain the logics, they don't explain the timing, why we need to clear, they don't explain anything. Even not only this, even to do the flow plan, they don't explain anything. Even if they want to explain to you now, just in the mails or like in front of the managers, just to show up there. So this industry really doesn't suits you guys, because in this industry now you have to be over enthusiastic, you have to even like small things you have to show it big. I'm saying it on the face because I have seen a lot of people, even currently also, yesterday also I have seen these situations. So these junior level guys, like they cannot survive in the industry. Like they can survive, but as in like suppose you have 6 years of experience. In these 6 years, like every one of your manager says this guy is worst. You have 6, but that guy says this guy is worst, or this guy doesn't know anything, or some your junior says, hey, this guy don't know anything, he asks from me only, or some senior says he is not at all, like he just do whatever the work I say, he'll just come, and if I say to do this, he'll do it, or else even like an layman can do, say like whatever if he say, he'll do that. And so that's how it, that industry is like this. So it can be happen like whatever things I am saying now, no one explains. And if you go to real time now, even your lead manager, junior, senior, everyone their own profit, that's it. At the end of the day, during the hikes I need 5 rating, that's it, and the hike. So for that, what all the cheap tricks has to be done, each and every guy will do that. How, like they lose the character, they lose everything. So that's how, that's what I am saying to you. Even I have seen, yesterday I have seen 1-2 juniors, like this, they are going through this. I cannot do anything because they are in under some other leads and all. They are going through that. So that's how. So you should be enthusiastic. You should learn more from yourself. I am saying now, hardly some 1-2 months of your life. You have wasted 25 years. Suppose you are not wasted, but you have enjoyed some 25 years of life or something. Now you just spend one month, that's it, on logical thinking, on like to build your career now. So that's how this 1 month may change your life. Or else now in this industry, like you guys cannot survive. Really, I'm saying this is the worst industry in the world. All selfish guys, all this I don't like this Andhra and not people. Really, I don't like, because in front of managers only they'll point something, they'll learn something from you. I'm saying the real example. I'll give you the real example. This simple. There nothing happened to me. Don't worry. I have my own recognition. Don't worry. I'm saying because I have seen 1-2 year guys. They came from university as an interns and they got jobs of 1 year. But they just have to be learn something, like to be new in college. Like they have said explained something and we have to write exam. So it will not be like that. So they have to build on their own career. Just in 1-2 years, their name will be like, okay, this girl doesn't do anything. Just she'll do whatever I say. So it should not be your name. Like if you got that name now, you cannot remove that name. So in this classroom, you guys may think I have explained extraordinarily. You guys may think I am worst guy. I have not explained anything. I am just showing some more magic to you, whatever it might be. Showing some magic to you, and like as a business people, they'll say nah, they'll show the big aeroplanes and they'll make you to walk on the roads now. So that's how I may do that. But you can understand, you have a certain age and you can understand. So you belong to my industry only. You may work in Intel, Qualcomm. So you will spread my name, that's it. It is not your fault. I have shown my good or bad to you, that you will prolong. However, if I next time when I met you with your friend, that guy will ask, who is this guy? This is my senior, or like he is my trainer, or he is some XYZ. Hey, that guy is worst guy, he don't know anything, I used to take him. it will be there. So if in 1-2 years if you got that name na, our industry is like compared to software it is 1%. If you got that name na, you cannot remove in your lifetime. For that you need to, like, even if you perform very hard like some other extra things, or else you have to do the same politics. That's it. No other things you can do. Politics. So that's why you please just spend one month. So it is just only like in future you should not fear about the work. I have seen many 6-7 years guys, now they are crying. I am saying now, yesterday night also I spoke to someone. That guy is crying. He has 6 years of experience. He is saying, I have tape out. So you just, this is all simple things. You just no need to confuse. So what are the clock cycle I am saying? What are the flops I am saying? You just need to understand what is my input. So even in the industry also, what your manager expects, what your lead expects, what the inputs you have given, and what the, so whenever you go as an PD engineer or like some IR engineer, some STA or Floorplan, you just need to know your inputs. If you don't know the inputs now, you are my manager. You, like, I'm your manager. You somehow you came to a big company and you are working there. You don't know anything flow. I'll just give the def and you say I want the timing pass clean. I'll just give the def in the mail. I'll say okay. I'll CC all the managers, big managers, and I'll say please find this def and please run the PNR on this and I want the timing clean. So with the def itself you can do. You need netlist. You need SDCs. He'll give netlist, SDCs, everything he'll give. Still you can do. You need to know their own flow. You need to know how to open the tool. So that's what the thing. So you need to know what all you need as an input, and you need to ask that guy. This is the input I want. In the industry, that is the thing. So all these juniors now, they don't know the inputs. So their leads or managers, they'll just show off in the mails like you do this. That guy is like simple thing. With def we cannot run the timing. If we know that now, we will be clear. So we'll reply to that mail itself like with def we cannot do. We need netlist, SDC, and how to open the tool. I need, like, if you are a fresher or if you are experienced, I need SDC. Like if you know all the flow, I need these inputs. So with juniors now, these guys will play like this. They'll give some junk data, junk inputs because they don't know the things. So that's how. So you just learn what are the inputs you need, what are the outputs you need to give, and at what point. So some managers may ask end to end, but your limit is this. You have to do. You should never cross your limit. Your limit is this, and you have to do this only. If you do one step, if you go one step forward now, make sure you have to. Even if 100 steps, if you need to go now, you have to go. Or don't take one step backward. That may like spoil your career. So that's how. You just have given somewhere I went. Why all this happened? So I just gave some example.
You are not doing the things correctly.
You just be enthusiastic. You just call on each and every doubt. The problem is there now. In industry, I think you know the pain of the job. I think you have to know the pain of the job. You have to know the pain of like a trainer. You have to know the pain of like consulting. You guys now, till now you haven't asked me about like are there any openings? Can you refer us? Like I have this tool. Tool is there. Like you know the pain of the tool. Some guys don't know Encounter. Last week they said I'm new to Encounter. This week they are saying I'm new to Encounter. Guys, it's simple thing. You know the tools, you know the flow, you know everything. You can learn it now. You have it. You go to Martali, that guy's room, or you go to that guy's room. You take the tool now and then itself, and you learn now. This industry now it is good. I'm saying you now. 1.5 months back, I have seen Shitesh. In Intel, that guy is working with me. He's an intern. In 1.5 months now, he'll learn full flow. Really, I'm saying he'll learn full flow. And there is some other guys, their internship is done, 1 year is done, and 6 months is done, 1.5 year is done. Still they do like enter some inputs they'll come from the lead. Okay, less, they'll type the less. Space means they'll type the space. So that's how you should not work. You should be some proactive. You should not be that much proactive. You should not be this much. If you are that much proactive now, you also need to do some politics because somehow some guys will come do politics to you. You just need to be more care and more learn, the problem is like if you know something na, it's good to you only na. That's the thing. If you know na, you can confidently come like after 6 years na, you can train some other guys and you can say all this nonsense to those guys also. That's how you guys know the pain. You guys know the pain of not having a trainer in RVLSA or like a chipet or something. You guys don't know the pain of not having the tool, not having the real time experience, not opening the design, not having the design or whatever. Last time one guy in this institute only, that guy asked my resume. I have sent like I have one opening. Then I said like he asked me do I have any opening? I said okay, there is this, so you can apply. So that guy said I don't have resume. I said I forwarded that resume to him and you just prepare something and you show it to me. That guy just changed his name and he gave it to me. That's it. Even the projects he has put my project. That much silly guys. Like I am worried about you, man. Really. He just named he just changed his name, mail ID, phone number, and mother name, father name. That's it. So you know the pain. When you know the pain, you just work on that. And definitely, I'm saying you now, whatever the concepts I am saying you, even if you go to industry, you know value of that. But I cannot. The thing I want to is like I want to develop a flow from you, like how the flow works. I want to say you. Not all this theoretical concept, what is that, all those things. I just want to know how corporate company will be, how a flow will be there, how to debug the flow, how to see. Not I just don't want to say open the ICC, do this floor plan, do this report timing. I just want to say to you that if you got some error in the log file, definitely if you go to industry, every time you will see errors. How to debug that errors. If you got some issues in encounter, in design, in spef, or in I just want to tell you how to edit the netlist, how to edit the def, how to edit the SDCs, like how to hack all those, how to hack the flows. But still I'm stuck here only, like explaining the small things, because the thing is it's basic. You have done the training, you have to attend the interviews, but you haven't learned the clock getting. I'm not saying about this. From these many days you have the tools, you just learn and do. Okay, let's stop this, and you prepare. Like that AND gate will not serve. What is our requirement? Back to the topic, what is our requirement? Whatever the cell we have, clock getting cell, that cell should give a complete clock cycle. So that's all you need to learn, you need to understand. To a flock, we need to give a full clock cycle. So that whatever the clock getting we have, that should give a full clock cycle. So how we can give a full clock cycle? That small pulse is there na, that is a pulse, so that is a glitch. Functional failure will happen, so it should not come. So what is our thing? I'm just saying. So you guys have drawn this. So you guys have drawn this now. Whenever you guys have drawn this, it should come to your mind. This is a glitch, like glitch to the, like this is a wrong pulse to the clock. Like we cannot calculate setup and hold at this time period, because whatever the time period we have given is this. We have created clock with this time period and we are giving the clock this time period. To obviously setup and hold will be and it is functional failure. So you should think. So that means here, based on this diagram, what should be the output? Forget about clock getting cell. What is the logic of the clock getting cell? Based on these two inputs, what should be the output? What should we get? We should get every time 0, because this clock cycle it should not go. And what is the enability saying? You only on for this much time. So for this much time it should not on. It should not on at all. Suppose our enable signal is there na, here at 0 and this is at 15. Suppose our enable signal is at 0 and 15 now. Now what should be the output? It should give full clock cycles, these two, till here 20 it should give, because that 20 is also there. So it should give the output exactly whatever the output we have. So that's how, because then only the full clock cycle will go. So what is that functionality? What is the clock gating functionality? It will happen. What is the logic will can give our desired outputs? What logic will give? Whose book is it? So the simple thing is like we just need like you just need to think, because interviews now the simple thing. So last month I attended an interview. That guy asked me a bar AB plus a bar B plus CB equal to this, some XYZ. Prove this, he said. I have drawn the truth table. He said don't draw the truth table. I am drawing circuits. He said don't draw the circuits. Then how I should do? Only the equations, like formulas. I don't know the equations. I said I don't know maths. I will not do. That's how, like, that means even I know the concepts, I cannot explain to him. That's the thing. So that's how whenever we learn we should learn completely, so that unexpected questions will come from the industry. So you cannot expect for 6 years guys those questions, but we have expected. So that in the same way, if you start thinking little bit more then you can learn more things and then you can explore. You just need to connect floor plan and placement and clocks, all these CTAs, SDCs, what will be there in SDCs and why we need SDCs, clocks, flops, time period, clock, and you need to connect all these points, then only you will get some full picture. So that's how. The simple thing is like we can use OR gate. Even if we use OR gate also, the clock cycle will not come properly. Then what we can do is like we can use some latch. So some latch and an AND gate. So this is enable pin, and this question even if you become 10 years also, the interviewers will ask this question. So this is a clock, this is an AND gate, this is a clock getter. Suppose this is a clock getter and this is a level, positive level flop. That means whenever like it is level 1 it will take all the inputs. Suppose our data is changing here. So what are the clock input is this and the enable input is this. Then what will the output of the latch? It will be for this time, whatever the for this time is there, it will give this output. That means it will give some junk output. It will give some flop, small glitch. And at this glitch, even the clock is also high and this is also high. What AND gate will do? It will just propagate that glitch. Even still it is a like it will not serve our requirements. So what it should be is like it should be negative level. So whenever it is 0 then only it will change. So why I am saying negative means, so if we will analyze our design, why I am saying. So whenever it is 0, it will not do anything. It will be like off. And whenever it is 0, it will give input to output. So what happened? This input here it is 0. So for this much time, clock getting will be on. And whenever it is becoming 0 what are the input is there, that will be stable. That means for all this time till it gets activate again, it will be high. Sorry, enable signal is there when even enable till the enable is 0, it will be high. I'll draw some point. So this has changed here. This has changed here. So this is our clock and enable. So what is the output of our latch when it is? So when the enable is 0, it will be 0, like it will not give any output. Whenever enable is high, what this it will do? It will try to like it is negative level. So when it is enable is 0, it will give the output whatever here it is. So whatever the output it is, enable 0 this no, I just confused explaining all this. So the thing is like whenever enable is 0, it will give the full clock cycle. So it will draw full clock cycle, and whenever this is 1 it will not change the output. So that means it will maintain the output. It will go on like this until whenever it gets 0, and whenever it is 0, it will again read this cycle. So whatever it is, the cycle is output like what the clock is here, it is like this, and whatever the output will output of the land and this AND gate. So whenever this is 1 and this is 1, then only it will give the output. So what the output will get is like, so if we see here, here both are 1, so it will give 1. Here it is 0. By default it will give 0. It doesn't care about this. By default it is 0. Until this comes, so it will give this. Okay, and here it is 1. So until this is 1, it will give the same. See, it will give the output 1. Sorry, it will give the output 1. So that's how we got one clock cycle. Na? So that's how, whatever it is like. So what is this concept is like, we have to maintain the previous value, we have to maintain the previous clock cycle. That means whenever we need to get the full clock cycle na. So when we can get the full clock cycle, whenever we take the 0 inputs na, whenever if the input is freezed here, that means clock has raised, so output will be stable, because once it's raised, latch will not change the output. Based on this only it will give. This is directly given to the AND gate. That means this enable is AND gate, given to AND gate. Whenever if this is 0 or this is 0, it will be 0. Whenever the clock is 0, it will give the output. But whenever the enable is 0, it will give the output. But whenever the clock is 0, it will be 0. That means whenever the clock is off, by default AND gate will be off. And we just need to, okay, this simple. Whenever clock is off na, AND gate is off. So by default, whenever the clock is 0, we will not get any 1. Whenever the clock is 0, we will not get a 1 there. By default we will not get. The only thing we need to maintain is like, we need to get the high pulse of the clocks. How to get the high pulse of the clock? So we need to just give the enable. Whenever enable signals is 1 na, even if it may go low here or low here, but when it go low here na, it will give the output, full output it will give, until it gives a low again. Until if the low is become high na, even low becomes high also, the enable signal. If low becomes high also, the value will be stable. That means whenever the clock is 1, the latch is not changing the output. It is maintaining as 1. So that means, okay, I think I am confusing you guys. It is just simple. The thing is like, whenever clock, we need two things in clock period. We have two things. I have confused you guys. Now it's be clear. In clock period we have two things, because I am explaining like for the first time now. So I'm just want to read your minds. I got the figure out. So we have two things in the clock. One is 0, one is 1. Only two values we have, and we need to maintain the 0. Whenever clock is 0, we should not give it to the floor. That thing we have served by AND gate. Whenever clock is 0, we will not give 1 to the output. That means output will be default 0. And the remaining thing is that 1 we need to give. Whenever the clock is 1, we need to give that 1 to the output. Like the output, whenever the clock is 1, we need to give that 1 here. So that even that is served by, whenever the clock is 1, by default the AND gate will be 1. So whatever the input here, it will go here. So the only problem we have is like whether we are giving a glitch or not. That means, so 0 we have served, and 1 we can get the 1. If we directly give the clock here also, we can get the 1 here. But the thing is like, the enable may switch on at 1. Whenever it is 1 na, it may go down. Enable, if we go down here now, so if you see here, so this enable, instead of here, it is getting down here, it is going down here. So whenever here it is 0 now, whatever the output will give is like, whatever the input we get, it will give it the output. That's how. Hey, negative edge latch now. Yeah, that's what. So the clock pulse, so whatever the output will be like 0. I just confused by explaining to you guys. You got the point, huh?
Yeah.
So in clock cycles we have zeros. So whenever enable is changing in the middle na, so what the tool is going, what this circuit is going to make like, it will not change. Whenever from 0 to 1 it is going na, then only it will change. 0 to 1. Sorry, I just confused. Enable, this latch has two inputs, enable and clock. I'll explain you guys clearly, don't worry. I just confused. I'm thinking. So this 0 is served by AND gate. You got the point. And this clock, this latch, it should give only the ones, full ones. That too full ones. When we can get the full one? In between, if the enable is high, it should not give 1. Only after it is completely 0 and it is becoming 1, then only it has to give 1. Like if the only here or here or here, that means whenever the clock is beginning, at that time only it has to give 1. So suppose our enable signal is came down here. So here what latch will do? Latch will, it has to propagate this clock. But what is the clock here? It is level high. So it will not give output. It has to take this enable to here. But it will not take this enable here. It will take this enable here only at the low. So whenever this the enable is low na, then only it will take the output to there. That means from low to high. At this point na, it will not take. At this point only it will take. So when low to high it is going. Sorry. At this point only it will take. At this point, clock is at this point. Sorry. Whenever the clock is at low na, coming to low. So whenever clock is high, this enable will not give to the output. So however, this enable is always 1. So whenever here the enable is 1 na, then it will give 1, and the clock is stable because it is a negative level. Negative level, what will do? Whenever the clock is going down, this enable signal will be at the output. So here the enable is 1. This 1 will come out. This enable may change here. That means this glitch may happen. But what the level 0 will do? It will not impact the latch. That means it will maintain the previous one, whatever we had read. So even enable may 0 here. That means in this case, enable may 0 here, but the clock duty cycle will maintain. And at this point, it will give the enable signal. What is the enable signal we have? We need 0 itself. So that's how. We will give full clock. Whatever the period we have now, that duty cycle, that we will give to the output. I think you got point. Otherwise, confused here. So that's the line.
But interesting.
Okay, you guys enjoy. All the best for interviews. My target training in CTS is 60 PS and on other hand it's 70 PS, which is good. Actually the thing is like I'll explain it to you everyone. So the simple thing in interview, the guys may ask, so like what is the tran limit, what is the cap limit. It is just simple. So what tran affects? If we have more tran, more number of possibilities at 0.3 voltage to 0.7 voltage, that may, like, we don't know, we cannot expect, like it may give 1 or 0. If the input changes now, output may also change. So suppose there is a flock or there are two gate, like a AND gate. For AND gate, one input is having like tran is more. So from 0.7 to 0.10 like 0.3 volts to 0.7, that VT is there na? We cannot guess when it will be on, whether it is going to be on and off. We cannot. It is because PMOS and NMOS are both are opposite to. So but both are opposite. Either complete 0 it should want, or complete 1. But at 0.1 both will be short. So if we have tran more, the problem here is like we cannot explain that. That means there might be a possibility of metastability in flops, because if the clock tran is more na, at that time, so from 0.3 volts to 0.7 volt, we don't know whether flop is actually on or not. At that time, if the input changes twice, suppose in this period input changes twice, tool cannot get what the input it has taken, whether 0 it has taken or 1 it has taken, if it is changes 2 times. So what are the change? So that's why we need to maintain a short trans. And one more thing is like if it is on from 0.3 to 0.7, both NMOS will be partially on. That means both are short directly from VD to VSS. that means we'll have lot of leakage currents. So that is simple, that these 2 points we have. So suppose interior villas, we have our design is, our trial limit is 60. Suppose our trial limit is 150. Our trial limit is 150, but we got we have one design with 120 PS, so that is met, trial limit is met, timing everything is met. And we have one more design, the same design with 60 PS trial, that means worst trial is 60 PS, trial limit is 150 PS, but one design we have 120 PS of trial, worst trial, and one design we have 60 PS of worst trial. Both designs timing is met, everything is met. Which is helpful? Which is helpful? You want to tell me. You have the inputs. What are the inputs you have? Why? What is the trend? What is the effects of the trend you have? And what is our requirements? Timing, everything need to be met. In both the case, timing, everything is met. Then which design is most useful?
60 PS.
Why it is? Why?
The logic will be changing in identify. It's not going to be metastable state.
No, it will not go. Our limit is 150. Trial limit is 150. So one design is having 120 PS. So there is no concept of meta stability there. Or trial limit is met. Even 60 PS also trial limit is met. So then which design is optimistic? Like which design we can go forward, or which design is best? Always you are, I said 2 inputs, you are taking only 1 input. I said the other point also. Power we have. So here where from 0.3 to 0.7, it may take 0.1 seconds. In 60 PS tran, from 0.1 to 0.7, 0.3 to 0.7 volts, it may take 0.05 PS. Like, so the power we got. So that's all. That means you know the point, you know the power will be saved, and you got this question. You just need to link. You need to link all these things, like how it is going to be happen. That's how you got point now. How it is going to be happen. When you don't link, you'll definitely like think, oh, this might be a logical question, this might be magic, oh, tough question. I'll just say simple. So we have a design. Setup is made and hold is made. This is normal question I'm asking. So if the setup is met, we have hold violation. Can we forward the go forward with the design? Why we cannot go forward? More? Why we will give? I think this everyone has to learn this question. I think even you guys have seen all the questions in every VLSI page. This question will be there. That's why I'm asking, like, how detailed you went to that question. So why? More priority to the hold means like we can ignore the setup.
There is a small setup variation with the clock period adjustment we can make that. But in the
What?
case of hold,
In setup? One thing, be clear. What my question is, be clear. The set design, everything is done. You cannot do fix, you cannot change it. The silicon is out, man. There is a hold violation. Is it good? We can go for silicon if the design. Why? Setup is met now.
This hold is independent of clock.
Hold is independent of the clock means, then why? It's okay. Setup is dependent on clock. It's okay. Then what it means? She is working and she is not working. What? They both are women. That's it now.
In future, if you get the setup violations also, is there possible to fix the
Man,
setup?
the design is done. In future, there is no future at all. You have done the tape out. There is no future. It will go to the silicon directly.
Work on both worst case and best case.
For hold and setup both, we will work on worst case and best case. Then what's the thing? The thing is, it's simple. Like, what is a hold equation? Like, why we need to fix the hold? What is a hold equation? Not the max equation. Explain me the hold time. What it will do?
After wasting
Complete the sentence. No need to be.
the data will be stable.
What is hold check?
Data should be stable after the collection.
After the rising
There is a, whatever the data it is getting to the flop, it should be stable at least for this much period. Why it is stable? Why it should maintain that stability? You should get that question. Why it should be?
launching data, if you
Why it is
Data will be overriding. Data will be overriding actually.
data will be overriding?
Yes.
Why it will override? So the thing is same. So just now I asked the tran question na, so that is the same. So when the in between the tran, like when the tran is more, I said like if the data switches twice, it can change. But the internal meaning, what that meaning is like, I'll say a few more things also. The internal thing is like the tran is internal to the cell, but we don't know how the cell is taking the input. So just before I have taken something from this guy, he has given it in my hand, but I have not hold that properly and he has left it, so it will fall down. So in the same way, we have a D pin and we have Q pin. It has some tran. Every flop will have some, every cell will have some tran. There is like we cannot do anything with that. The problem here is like whenever we are giving some input, it is taking that input. Suppose before going to Q, it will take some time. Before going to Q, if the data changes, like who will guarantee whether the proper data is transferred or not? So that means that whole time will be there. He need to wait at least 1-2 seconds until I hold it. So that's the whole time. So the same thing is like when the so the whole violation is done. So here if that happens now, that whole time is not meant, then what it happens? We don't know whether 1 it went or 2 it went, 1 or 0, sorry, no 2, 1 or 0. It is not compulsory that data will change, but it may change. We need to maintain somehow with the resistance. We need to add the resistor. That's it. Once it changes now, that resistance has to be stable. Make stable this for 10 seconds. After 10 seconds only we are adding delay, means we are adding the resistance. That's it. So if the hold is not met, we don't know the functionality. If we get 0 or 1, like X we got now, then whole functionality, whole logic, whatever the thing we are working, it's waste of the time. That's it now. That's why hold is critical. But when setup fails now, what is failing when setup fails? If not in this cycle, no, I'm saying nothing is happening. Like if setup fails, nothing will happen. When setup fails now, that is also a problem. But the problem severity is like, if not in this cycle, at least in the next cycle it will catch the data. If not in this cycle, at least in the next cycle it will catch. However, the data will be 0 and 1. So what are the outputs we got? Functionally they might not fail you, but they may give delay error. That means one screen has like one pixel has on before, but the next to that pixel it has to be like bright or black or white, but it has been after one cycle, it has been that. So just one cycle delay. Even hold we should not excuse, and setup we should not excuse. But the setup is like we will calculate we use lot of pessimisms on the setup, lot of pessimisms. So that's why the thing is like setup we can 1-2 PS we can ignore, because in the industry in the real time that setup margin within we'll fix with 15 PS of margin, 15-16 PS of margin. We'll expect that much wars and then we'll manufacture. Even after expecting that much wars also, the yield is like hardly out of 100 chips they are manufacturing now, hardly some 10 or 12 they'll get the yield. That's it. That means out of 100 chips they manufacture, only 10 will work properly, remaining all will have some defects. Even the 10 will have some defects, but these guys will, if you go to Intel manual, Intel i-Core i7, if you go to that website, if you see Intel i3, that guy will give, I don't know that page what it called, but defects it will have, it will not work properly at some particular situations. He will explain at this point it will not work. Even with fixing that much pessimism also, it is not that one thing or other thing, it may go wrong. So that's it. So that is setup violations. So he'll say now these all things may not work properly. That means he has given some spec, but the chip whatever he got now, it is not meeting some 2-3 conditions. That's it. So that is minor, but chip can work properly. That's why they have taped out. So that 2 3 they have not they have mentioned like it is not meeting na. That is what the setup time is. So setup time they have, it's okay, they leave it. ఏమంటారు రెడ్ బుక్ I think I'm not getting the point. Manufacturing the not manufacturing the faults, but some extreme cases where it may fail, it will. So that's how the design has hold violations, that functionality itself is failures. The hold fails if not in the cycle, in next cycle it will change, but one cycle
Become zero.
hold
Become zero. We can make zero.
hold become zero means
I mean, we can make whole zero. Like you told me, if we have set up like
I think
previous and
okay.
versions, we can.
I am saying, so the one thing with you guys is like you guys please learn some like concepts. STA you go through, you have you gone through STA, have you gone through ICC user guide, all those things, it's better if you have gone through. So the thing is like I'm saying it to you. So that hold and setup times are there na, it is just simple. Normally we don't see these physical things, we just draw some AND gate, input and output. What is that setup time? Why we need that setup time means, so as a flop, if I draw some in the book, so if we draw in the book, we say this is CLK, this is D, this is Q, these all things are there. So we have stated at single point they are on the same page, CK and D, and they are on, like output is on the same page, Q and Q bar the same page. But practical this will not work. Practically what happened is like this is a D pin, this is a CK pin. What the tool calculates is like, if you see in the library or something, what tool calculates is like, some M1 will make like M2 will come here and it will connect to this, some metal layer will come and connect to this. Suppose this is D and this is CK. The thing is here like it calculates until reaching here only. It calculates until like it is said this data has got at this point and this data got at this point. So sorry, this is VDD, I'll show these two. So these two, D and CK. But what it has to be done internally is like this data has to transfer, like this data has to go to some transistor, then only this data is valid. Or the input we got na, it has to cross some transistor. Suppose some 10 at PS, some like 0.01 PS the data reached here, and some the same 0.01 PS the data reached here. Tool calculates until then. But analog, but what are the internally, what are the logic we are given? It has to go through some transistor, some switching has to happen, some NMOS has to on, PMOS has to on, and it has to give the output. That output will cross 2-3 transistors here, CMOS, then it will go to the Q or Q here, go to the Q here. But this 01, it is giving clock coming at 0.001 PS, D is coming at 0.01 PS. But what are the clock input, that corresponding poly will be there now, that OD and poly, OD will be there like this and poly will be like this. So it might be near. So it can take hardly 0.0001 PS, 0.0001 PS, 3 zeros and 1 PS. It will take only that much time to reach from this pin to this transistor. But from D pin corresponding resistor, transistors will be there na, CMOS. It may be here, or there might be 2-3 levels, then only it will go to Q. So but to get effect after the of the D pin input, it has to cross some 1-2 transistors na, that may take 0.0002 PS. Or clock may, like what here happened, clock has raised, after 0.0002 ps seconds this has got on. Sometimes it can be before. This may take 0.0002 ps, data can be 0.0001 ps. So data was even early, then clock has arrived, then it has taken. So these delays will be there now. These all things will be in the library. So that standard cell will work how like this. This standard cell will work like this. So it can be positive. Suppose I am saying library setup value is what? What is that library setup value for the flop? C2Q value na? C2Q value. Don't confuse. It's okay. I think I'm explaining in the normal language only. I think as a normal points. I'm not showing these as a big thing and like I'm confusing you. I'm as a normal things only. I'm explaining it to you. The thing is like so the C2Q depends on what are the C2Q delay we got in this library. That is this based on these internal things. Actually, why we got into this point, man? You have asked something. Yeah, hold. So that's it. So that C2Q or library setup time, that C2Q delay depends on this. So when the clock is came, I'll explain in the like numbers only. This clock and this is got at 1 ps. They both has got at 1 ps. But this clock, to activate that clock, it has to go through the poly and OD, then transistor NMOS, PMOS should on, then only D pin will take the output. D pin output will transfer to the output. I think you guys are following me. If we got the activate the clock, it has to go through poly, OD, NMOS, PMOS, then only D pin input will be taking at the output. For just for understanding, I am saying normally what we expect is like this clock is like it is taking to switch on the clock internally, that clock corresponding it is taking 0.1 ps. So to get here we got 1 ps. From there we got 0.1 ps. That means 1.1 ps delay to switch on. For D, it is taking 1 ps till here, and to switch on that it is taking 2 ps of delay. So now what the library setup time will be? Delay between these two, 1 ps. 1 ps positive. That means data can be like positive. Suppose data is getting first. They both are getting at 1 ps. But corresponding data logic is here only. Corresponding clock logic is somewhere distance. So data is taking to switch on the data is taking 1.1 ps of second to switch on the transistors. But for the clock it is taking only 0.1 ps of to switch on. So 1.1 ps. That means after getting the clock only the data is getting. So how the library setup 0.1 ps of data, 1.1 ps of data and 1.2 ps of clock. That means data is already available. So the library is stable time. The stable time what? So if you understand what are the library stable time is in, this is at CK, this is D. D should be stable at this point. But D here it is coming even before. So then how it will be? Even it will be negative. That means setup library setup value will be even more. If it is coming this side, so D by default in design CK is coming at 1 ps and D is coming at 1 ps. So then you guys may say that then no need of library setup value, they are coming at equal point. But what library setup value will take is like sorry. So it has to take with what is called library setup value is 2. So if CK is coming at 1 ps, D is coming at 2 ps. Suppose this library value is 1. Suppose. So by default the clock is met already. That means hold is already met. CK is coming at 1 ps and D is coming at 2 ps. Hold is met. We have that 1 piece of library setup value is met. But for suppose it is theoretically when we up to this point only. You got some point, huh? Whenever clock rises, some hold time will be there. Suppose the clock is coming at 1 ps of delay and like 1 ps of time frame it is coming, and whole library setup time, library hold time is 1 ps. So that data should come at 2 ps only. Before that, if it changes na, hold violates before that. So by default data is coming at 2 ps, so then hold is not violating. For suppose in library, what it may happen is like internally till then we have seen like this is coming at 1 and this is coming at 2, but to switch on it may take 0.5 seconds, 0.5 ps, it may take 0.1. so to switch on, now we will calculate switch on thing. So if we add the switch on thing, clock will be 1.5 ps and data will be 1.1 ps. See, sorry, 2.1 ps. Now what's the difference? Previously we have 1, that 1 is the library setup value. Now what we have, it is not 1 practically when we go to the transition level. So that setup values, library setup value and library hold value is there now. That depends. You can go through the STA, static timing analysis. Maybe like the thing is like I might explain good or explain bad. At least you need some data to read. So whenever you read, then only, and that too these concepts it has to be in mind, so that at least you go through this topic. So that library setup values and hold values depends on how it crossing these CK and D pins are there. How when they are switching on internally, whether D is switching on first or CK is switching on first. So based on that, library values will be negative. If you see that, it will be like you can understand that. So then if you read once now, I think you guys can understand even better. Then you will have some questions, then I can explain even better. Without questions, no teacher can explain perfectly. Questions has to be there, doubts has to be there. For now I'll stop this year. I think I have repeated something. if I'm repeating something now, you guys just say like it's because I see question mark, like if I see anyone is like face is like question mark, then I'll repeat it again. It's waste of time. Just only if I repeat once now, that guy may understood. So that's how I think. Okay, it's done. You guys can attend the interviews, man. Bye. It's already 2. Any more questions? DLS మన గ్రూప్ అందరూ అనుకున్నారా? మన గ్రూప్ నేను కూడా
How to remove white pool, floating things and floating steps, floating
actually we have, I think, remove floating shapes we have command, remove floating layers we have command. Yeah, pins are different, wires are different. For remove for shapes we have command, for pins we have command. Yeah. Even for ports also we can get the what are the ports is floating, we can get. To remove, normally to remove a port, it is normal, remove port, that name we have to give. But you want to remove only the floating now, first you need to get that floating ports, then you have to give that name. These targets, queue, insertion delays, and these values are there now. You just sit once. I have not listened to your question, but for now I am saying I will listen to you. But for now, you draw designs. How skew affects? You have to at least make 4 examples between the flops. So skew is here like this, skew is here like this, skew is different in 4 cases. How it will be? Then you will get one skew understanding. And if you draw like 4 different lattices, then you will understand. So what's your question?
The tolerance skew is not meeting.
Okay.
How will you check that your resources in your
How we check that?
How you will analyze the reports?
With the report.
What are the things you will
Analyzing is like it's
what are the things
okay.
you
It
will
might be
check?
some. Okay, the thing is like it is simple. The question he might ask like what are the whatever that you have written. His intention is like how the skew affects the timing, and how you are going to check it is only because of skew the timing is violating. So it's just simple. I think you guys understood the question at least first. So the thing is like we have I've shown you that report timing part now. So even before that also, like it's better to first thing after the placement or after routing, the first thing I'll check is like the first validating path I'll check. So there you can check data path is optimized. So first they will be having some clock pin, clock root pin, and clock latency, like clock latency, clock network delay, and then buffer, all those things, and then CK pin it will come, then Q pin it will come, from Q pin it will come to D pin in the data path. In the clock path it will come from root clock pin to like input in clock source latency, all those things, and then it will come to CK. So you just check what's the value at this CK and what the value at that CK. I'll check first. So before that making that statement like it is only because of Q, you can check the stand cell path. So stand cell we cannot optimize anything, but we are seeing the delay just because this CK is getting at 10 ps, but in data path the CK is getting at some 30 ps. That much difference it should not be. We can make some little bit values like 10% of our clock period or some 15% of our clock period, we can vary insertion delays, but we cannot, that difference should not be like this is 10 ps and that is 100 ps now, then it's gone, like it's almost some triple, like 5 times. So it should not be like that. And how you analyze is like it's up to you. You can like just after completing the routing, you can just go and check okay, what is the skew values, whether it is in the limit, no, I'll report it, whether you can do that also. But practically what we'll do is like we'll check the report, we'll check if the data path is going to fix or not. Data path is optimized because that much skew, like in data path it cannot withstand. So we can check in the CK to CK, we'll check. So here the skew is more, then what is the fixes, we'll somehow do like macro modeling or like deleting the buffers based on the previous I think you guys know. I think the question you understood now. The question is, he is asking like our design is failing because of skew, and how you analyze that. If the question you have understood, you know the answer, that's it. You got the answer at least, I'm not confused now. That's simple question. I think we can check it. We can check the clock reports. Suppose there are conditions, even the insertion delay and the skew is met, like insertion delay is violating, skew is violating, we got the timing path is met, then who cares? They are virtual thing, they are they are not the physical thing, they are logical constraints we set so that it helps our physical things to be done correctly. So skew is not a hard code limited, insertion delay is not a hard coded limit until we met our timing, like that's it. Our timing is clean, skew, insertion delay, whatever it is, we don't care about that. Target skew value, it depends based on your project. Normally you say, normally you use only 28, put only 28 nm or 40 nm projects. You say like latency is 700 ps and clock skew is 300 ps and my clock period is 1 gigahertz. You calculate the time period. 1 gigahertz is a clock. Any more doubts? You guys are going to interview now you can ask all the interview questions also. Don't worry.
Explain how to
So the one thing I said now, you just have to impress him like in the way. To impress him also you don't need any magic, you just use the words so that the word should be like you have done that experience, you have that experience. If that guy asks like if like I have a design like skew is not meeting and like insertion delay is not meeting, but the timing is good. How come it can be? You just say it can be you guys don't say like it can be made because skew and like insertion delay is only virtual things. We only said so that our physical things can done properly. Don't say like that. You say yes sir, I have seen this issue in the last project. That's it, done. I have seen this issue in last project, and later after that you say what are the nonsense it is. Somehow you'll make that as a sense, because you said in the last project you have seen that. Oh, this guy has seen that, so he's saying something means he'll at least learn something, or he'll think that okay, he's trying to say something but he has seen that issue. He might not present something properly. So that's how. Yes sir, in the last project I have seen this issue, so where that insertion delay value was limit was 700 ps, but it went up to 900 ps for few flops. You should be more practical. For whole design it cannot go, so only for some 10 flops it went to 900 ps, and like skew almost like limit is 300 ps. Because of that I have got some 450 ps of skew or 600 ps of skew. Limit is 300, we got 550 ps of skew. So what we have done is like so there is no interrelation, like we have set max skew as 900 ps. It is not needed that we need to worry about like what is the value I need to say about the skew, because the skew value is globally. So the least path may be 100 ps or 400 ps, so you can say some random value 600 ps. If that guy asks if the skew is insertion is 900 ps and skew can be 600 ps, means you don't worry, it can happen sir. So it happened, so you have to be that much practical. So it went like that, but our timing has met, but our designer has, then he'll say if the timing is met, why he might think if the timing is met, why you have seen that skew and incidentally. Normally PNL guys don't see that report, at least the report they'll not open at least. Then why he has seen that and why he is saying like I have seen the previous issue. You know, to say actually there is a clock team, so it happened, timing is met, but there is a clock team or my lead is there they have like she maintained, like we have a constraint. You can say like we have a constraint, like insertion delay should be 700 ps only, and even the top level team has asked like some like whatever the team it is, sign off team asked us to maintain only 700 ps, but I have explained them timing is met, and this has to be met with this only. It cannot be like I cannot even change the skew or data path. So that's how so that's why I have seen that insertion delay and skew has not met, but the timing is met. So like you have to satisfy him here logically. Any more questions? So whenever interview asks now, you just think once. So it's a simple thing. I think I don't waste your time, but in 2 minutes I'll say the computer like always gives the definitely correct input. What are the required? Computer never fails. You know why? Because it knows what the inputs it needed. It needs zeros and ones and in correct pattern. If you give the correct inputs, I'll give the correct input. That's it. So we always make sure we'll give the correct inputs to the tool. So if you give correct inputs to someone, definitely we expect the correct output. So that's how. In the same way, even in life also, or interview, in work, you just make sure what are the inputs you need. If that guy says has some random question, so we have an SI in our design, so how do you fix that SI? We just need to know what are the inputs. So if the SI means it is already routed, and some basic things, there is a cap difference, there is a load difference, and we have to say so this is the SI, and you have to say in the last design like in the last project I have seen SI violations are where what I have seen is like there is a tran violations because of the SI. What happened is like we had run previously like without the SI the trial limit was met, or like the setup time and hold time between some bus is there, that bus has met, but when we are running with a PTSI that SI is not being met. So there I have seen the problem here is like those nets have been straight like almost for 300 microns. Those nets have been parallelly going on with the parallel with the clock path. So that's why what you have done, you say what are the nonsense you want, but it should be logical. So like how I'm explaining practically, you explain them practically. So if you say assignments like you draw the waveform, that doesn't impact it. So it's done. I can go. Don't mind, but all you guys can send your resumes to me. I don't know anything with the resumes. I don't want to also. Yes.
Modified applications.
And even I don't modify your resumes also. Just give me your resumes. That's it. And if you are okay with it. Resumes.
క్లియర్ ఆన్సర్ ఇచ్చినప్పుడు కూడా అర్థం కాదు.
Guys, today are you satisfied? ఏమైందమ్మా ఓకేనా మళ్ళీ మధ్యలో actually one good suggestion to you guys is like